so this video is kind of long. It's about making Lewis structures for ionic compounds. What you can do is you can pause it. You can fast forward it. Go ahead. If you think you got how to do it, go ahead and complete drawing them. You don't have to print out the worksheet. You just have to know which elements you're going to be combining in your ionic compound. And draw the Lewis structures on your own paper. Then check them with my key. If you get something wrong, then look at the video. You don't have to watch the whole video. But I would like to recognize some of the contributors into the video. This is Bella. Hey, Bella. Bella. And this is Nina. They helped. And Gus. Gus, did you help? That's Gus. Did you help? Yes, I did. Anyway, watch the video, draw some Lewis structures for ionic compounds. Email me if you have any problems. Bye. Okay, in this video, I'm going to talk about ionic bonding and how to draw Lewis structures to show how ionic bonds form compounds. As you see right here, we have a very funny cartoon. It's got a bunch of atoms, and here's the teacher atom, and the teacher atom is saying, perhaps one of you gentlemen would mind telling me what is outside the window that you find so attractive. And if we notice, all of the ones inside the classroom, lithium, sodium, potassium, cesium, rubidium, those are all group 1 elements, alkali metals, and they're way over here on the periodic table. So these are the most reactive metals of all the groups. Outside the window, we see fluorine, chlorine, bromine, and those are halogens. They're way over here on this side of the periodic table. These are the most reactive nonmetals. So anytime you get a group 1 element, like sodium and lithium, potassium, rubidium, cesium, and they get around a group 17 element, like fluorine, chlorine, or bromine, they're very attractive and they form very strong bonds. They form ionic bonds. Ha 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 ha. Okay, so this is the worksheet that I put on Google Classroom, and what you'll notice is that you don't have to print this out, okay? All you have to do is know which elements that you're going to do. So it's going to give you 2 elements. Here we've got potassium and bromine. And then you're going to draw the Lewis structure for the cation. Remember, cation means it's a positive ion, and the anion is a negative ion. Now I got kind of tricky on some of these, like here, where calcium is the positive ion and that one's the negative ion. I switched the order on them. Don't let that fool you. And so I've done potassium bromide as an example, but I'm going to show you how that actually happens. Okay, so the first thing we start off is we're going to draw the Lewis dot diagram for the elements. Remember, the Lewis dot diagram is going to show just the valence electrons. All right, so here we have, the wrong page, here we have potassium. Potassium has 1 valence electron. Okay, and there it is, right there, that red dot. There's our valence electron right there. Okay, now let's look at bromine. Oh, potassium, it's in group 1, 1A. That tells you how many valence electrons it has. Now let's look at bromine. Bromine has 7 valence electrons. We know this because it's in group 17 or 7A. And there's our 7 valence electrons. Notice we got 1, 2, 3 pairs, and there's 1 lone electron right there. Okay, so now let's look at the Bohr diagrams. Remember, we did Bohr diagrams before. And so here's the Bohr diagram for potassium. Potassium has that 1 valence electron out there in the 4th energy level. Remember where it is on the periodic table? Is in group 1, period 4. 1 valence electron in the 4th energy level. That's what the periodic table tells us. And there's that 1 electron right there. Okay, so that is what potassium is going to look like. So what potassium is going to do, because potassium wants to have a full outer shell, like all electrons, is potassium is going to lose that electron. All right, you can see the electron leaving there. So potassium is going to lose that one electron. Now, the third level of electrons has 8 valence electrons in it. It's full. Okay, this makes potassium very happy. Okay, so this is the goal of every atom. So now let's go look at the bromine. So here's the Bohr diagram for bromine. It's got 2 electrons in the first, 8 in the second. Actually has 18 in the third energy level, but it has 7 valence electrons in the fourth energy level. Wow, it's just needs that one more electron right there and it'd have full 8, right? All right. So here's the 7 valence electrons in the fourth energy level. So what's going to happen, you remember that electron that left potassium? Well, it's going to come over there and it's going to join. See, it says, hey, come join us. It's going to join those 7 electrons over there in the fourth energy level of bromine, okay? And so now bromine has a full outer shell in the fourth energy level. It has 8 valence electrons. 8 is great. That's the goal, all right? So here's what's going to happen. So here's potassium. Now I have 19 protons and 18 electrons. I am positive. See, because it has 19 minus 18, that's a +1. So potassium is now an ion. It has a charge. Now let's look at bromine. I have 35 protons and 36 electrons. I'm negative. 35 minus 36 gives you a -1. Bromine is now an ion. By the way, when nonmetals become ions, they change their name. Bromine is now called bromide. So now we have positive and negative. And you know what they say about opposites? They attract. All right? So I find you very attractive. So potassium and bromine, they fall in love. And so now we have the ionic compound for potassium bromide. One potassium ion will combine with one bromide ion. Opposite charges attract. The overall charge in ionic compounds is going to be 0. In other words, they can combine in a ratio such that their positive and negative charges will counteract each other. Okay? So when we draw the Lewis structure, notice I made the electron for potassium. I made it red so you can see where it goes. It's going to go over here to bromine. When we draw the Lewis structure, we put potassium in brackets and we don't put electrons around it, even though we know it's got a full outer shell. But what we're trying to show is it's lost electrons. And now it has a +1 charge. Anytime you see just a plus sign, that means +1. The cool chemists don't write the 1. If you want to write +1, that's fine. Now bromine over here has gained that electron. It has a -1 charge because it gained an electron. So this tells us that potassium and bromide will combine in a 1-to-1 ratio. And that means the chemical formula is going to be KBr. When we write chemical formulas, we don't put a subscript of 1. If we needed 2 potassiums, there'd be a 2 there. But we just need 1, and we don't write 1s. Okay? So, let's look at this very quickly here. Key points to remember. Metals lose electrons to form positive ions. Nonmetals gain electrons to form negative ions. And positive and negative ions are attracted to each other. Okay, that's the whole key thing behind all of this. All right. So now let's look at the next one we're going to do. Gallium and chlorine. So the first we're going to do is we're going to draw the Lewis structure for gallium. So we're going to put the symbol Ga right here. This is where we use our periodic table. And we know that gallium is right here, and it's in group 13 or 3A. So how many valence electrons does it have? That's right, it has 3. So we're going to give it 3 dots. And what I'm going to do is I'm going to give them a little halo of color. So we know which electrons came from the gallium. Now let's do chlorine. Chlorine is our anion, or our nonmetal. And we draw the symbol for chlorine. We find chlorine on the periodic table. And there it is. It's a halogen. It's in group 17, or 7A. How many valence electrons does it have? That's right, 7. So we're going to put 7 dots on there. When we draw valence electrons on the Lewis dot diagrams, we want to draw all our single electrons before we do doubles. Notice there can be a pair on each side. So we're going to go 1, 2, 3, 4, 5, 6, 7. So we can see that chlorine has 3 pairs of electrons and 1 lone electron. If it could just gain 1 electron, it would be full, right? So here's what's going to happen. So here's our friend gallium. And gallium's got its 3 valence electrons. And I would put color on them so we know which ones they are. And here's our chlorine. And it's got its 7 valence electrons. And so gallium, it's a metal. What do metals do? That's right, metals lose electrons to form positive ions. So gallium's going to take this electron here, and it's going to give it to chlorine. Now, chlorine has a full outer shell. Chlorine also has a -1 charge. It's a chloride ion. But what about these other 2 electrons? Gallium needs to get rid of them. So how do we do that? Well, we get another chlorine. And then this electron here will go down there. And now we have 2 chloride ions. Oh, but wait. Gallium still has this other electron it needs to get rid of. That's right. We're going to get another chlorine in here. And it's going to take this electron here. And it's also going to be a -1 ion. Okay? So now these 3 electrons, they're gone. So gallium has lost 3 electrons. So guess what its charge is? Well, you can tell because if you're in this group right here, there should be a +3 written up here. It should be a +3 ion. In fact, I'm going to write my charges on this periodic table here because I forgot to write them on this one. So remember, if you're in group 1, you're a +1. If you're in group 2, you're a +2. If you're in group 3, you're a +3. If you're in a group 4, you know I said plus or -4. Actually, if you're in group 4, you're probably going to form a covalent bond, not an ionic bond. If you're in group 15 or 5A, you're going to gain 3 electrons and be a -3. If you're in group 16 or 6A, you're going to gain 2 electrons and be a -2. And if you're a halogen, you're going to gain 1 electron and be a -1. And of course, noble gases, they're already full. They don't need any electrons. They don't lose any electrons. They're good. All right. So that's why we would have, where'd my worksheet go? We would show this as, here's our gallium. It has no electrons because it lost them all, right? Well, not all of them. It goes down to the 3rd energy level, but it's going to be a 3 plus. That's how the cool chemists write it. And then we're going to do a chlorine. It's always good to do the bracket on this side, then this stuff, and then there. So your nonmetals are going to have 8 electrons around them. But this one, that one came from gallium. And then we have 3 of them, right? And that one came from gallium. And that one came from gallium. So we see there are the 3 valence electrons that gallium used to have, but gallium gave them to the chlorides. By the way, metals, they like giving up their electrons. That's what metals do. They're happy when they give up electrons. And the nonmetals, well, they're happy when they receive electrons. So it works out pretty good. Everybody's pretty happy about that. So now we're going to write the chemical formula. We have 1 gallium. Remember, we do not write subscripts of 1, okay? And we have, how many chlorines do we have here? I see 1, 2, 3. And so there is our formula for gallium chloride, GaCl3. All right, let's look at oxygen here and calcium, okay? Calcium is the metal, so we're going to put that one here. Sorry, I tried to be too confusing and cute here. Shouldn't have done that. So calcium goes here. Now, how many valence electrons does calcium have? Let's find calcium on the periodic table. Why, there's calcium right there. Calcium is in group 2. So guess how many valence electrons it has? That's right, 2. So 1, 2. I knew you could do it. All right, and we're going to color them because we know those are coming from the metal. Now we're going to draw oxygen. The symbol for oxygen is O. And oxygen, what group is it in? Why, there it is right there. It's in group 16 or 6A. How many valence electrons does it have? Good. Yes, it has 6. So we go 1, a 2, a 3, a 4, a 5, a 6. So when we look at the oxygen, we can readily see, hey, there's 2 pairs right there, but there's 2 single electrons. What do you think is going to happen there? Do you think calcium might give an electron to there and an electron to there to fill oxygen? Well, that's exactly what's going to happen. So calcium is going to lose 2 electrons and form a +2 ion. Because remember, metals lose electrons to form positive ions. All right. Now we draw our oxygen. And it's gained 2 electrons, so it's a -2. And let's see, it's this one right here. And it's this one right here. Those 2 came from the calcium. By the way, look. +2, -2. What does that equal? That's right, 0. And if we look up at this one here, I forgot to do the math up here. +3, -1, -1, -1. That equals 0, too. Remember, ionic compounds, they want to form a net charge of 0. The positive and negative charges are going to cancel out. So now we're going to write the formula for calcium oxide, because oxygen becomes oxide when it becomes an ion. And remember, nonmetals gain electrons to form negative ions, right? So we have 1 calcium and 1 oxygen. So the formula is just going to be CaO. All right, let's do barium and chlorine. Okay, of barium and chlorine, which one's the metal? That's right, barium. All right, and barium, let's find barium on the periodic table. Where is barium? Why, there it is right down there. You know why it's down near the bottom? Because it's barium. Anyway, all right, barium is in group 2, so it must have 2 valence electrons, just like calcium. Notice that elements that are in the same group, they have similar properties because they have similar numbers of valence electrons. And chlorine, remember chlorine. Chlorine is way over here in group 17. Chlorine is a halogen. It has 7 valence electrons. One, two, three, 4, 5, 6, 7. Now let's color code barium's electrons to see where they go. Now, we can readily see that this electron right here is going to go there, okay, to fill up chlorine. But what about this electron here? Well, remember what we did for gallium? We got another chlorine, so we're going to need another chlorine. So barium is going to lose 2 electrons and become a +2. And we're going to have a chloride right here. And it's going to gain an electron because that's what nonmetals do. Now remember that nonmetals gain electrons to form negative ions, right? All right. And so now we need another chloride to take that other electron from barium and right there. So you see there's the 2 electrons that came from barium. Of course, that's going to be also a -1 charge. +2 minus 1 minus 1 equals, that's right, 0. So when we write the formula, we have BaCl2. All right. Now we're going to do oxygen and lithium. This is another one of those ones where I was trying to be tricky and I switched the order. Don't forget that lithium is the positive, that's the metal, or the cation, and oxygen is the nonmetal, or anion. Okay, so lithium goes here, and lithium, let's find lithium on the periodic table. Where is lithium? Why, there it is in group 1. So it's going to have how many valence electrons? That's right, 1. So we give it 1 dot right there, and we're going to color code it. Now we're going to draw oxygen. Here is oxygen. Oxygen has 6 valence electrons. We know this because, well, it is in group 6. I'm sorry, 6A, 16 or 6A. All right. So we readily see that lithium is going to give this 1 electron here to oxygen, but you know what? Oxygen needs another electron right there. Whatever are we going to do? Well, just like up here, where we got another chloride to accept an electron, we're going to get another lithium to donate another electron. So we're going to have lithium, and this one's going to give up 1 electron and be +1. And we're going to get another lithium to give us another electron. And then we're going to have our oxygen here. And of course, this electron here came from 1 lithium, and this one here came from another. Okay, so now we write the formula. So how many lithiums do we have there? We have 2. So it's going to be Li2O, because we have 1 oxygen. So lithium and oxygen are going to combine in a 2-to-1 ratio. All right, so let's do sodium and sulfur. So here's sodium. Sodium. Why, it's in group 1. It has 1 valence electron. And then we have sulfur. It has 1, 2, 3, 4, 5, 6. Now, if you're really paying attention, you'll notice that this is a group 1 and a group 16. This is a group 1 and this is a group 16. They're going to combine in the same ratios because they have the same numbers of valence electrons. Okay? So we're going to have 2 sodiums. Each sodium is going to donate 1 electron and become a +1. And then we have our sulfur over here. Sulfur is going to accept those 2 electrons because that's what sulfur does. And it would be this one right here. That's from that one. And this one gave that one right there. And so we would have Na2S. That is sodium sulfide. All right, let's go to the second page now. Let me find my second page. Here we go. All right, so now we're going to do phosphorus and potassium. Remember, potassium's the metal, phosphorus is a non-metal. Okay, and so our good friend potassium has 1 valence electron because it's an alkali metal in group 1. And then phosphorus, where is phosphorus on the periodic table? Do you see phosphorus? Point to phosphorus. There it is. Phosphorus is in group 15 or 5A. Okay, so when we draw 5 valence electrons, we're going to go 1, 2, 3, 4, 5. So when we look at phosphorus or nitrogen, what we're going to see is there's 2 paired electrons right there, but there's 3 single electrons. And think of those single electrons as bonding sites. They're places where atoms can combine. And so you can see what's going to happen here. This electron right here from potassium is going to go over here. But we need 2 more. So we're going to need 3 potassiums to give us 3 electrons, because this needs 3 electrons to fill the outer shell. We need 1 there, 1 there, and 1 there. And so 1 potassium, 2 potassium, 3 potassium. And then we have a phosphide. Remember when they become an ion, they change their name to ide. And it's got its full 8 electrons there. It's gained 3 electrons, so it's a -3 now. And so there's a gained electron, and there's a gained electron, and there's a gained electron. Each potassium gave 1 electron to phosphorus. So now we have 3 potassium, 1 phosphorus. So we have the chemical formula of K3P. All right. Now for the hard one. Oh boy. Aluminum and sulfur. All right, which one's the metal? No, it is not sulfur. Aluminum is a metal. Aluminum can, hello? Come on, you know that. All right, and sulfur is going to be our anion here. So aluminum, and where is aluminum on the periodic table? Let's look here. All right. And there it is in group 13 or 3A. Aluminum is going to have 3 valence electrons. And I'm going to color code those. And here is sulfur. And sulfur is in group 16 or 6A. It's going to have 6 valence electrons. So it's going to have 2 pairs and 2 singles. Sorry, some of the marks have bled through from the other side over there. Try to ignore those. All right, so there's our, that's not an electron. That's just a mistake there. All right, so I'm going to go over to the paper here to draw this one because it gets pretty complicated. Oh, look at all those dots. All right, so here we go. When we have aluminum, and it's got its 3 valence electrons here, and we have a sulfur with its 6 over here. And there's color coding. Now, obviously we know that this electron here is going to go there, and that one is going to go there. So now this sulfur is complete, and it's a +2. But what about this one electron here? What are we going to do about that? Well, let's get another sulfur out here. So we go get another sulfur out here. And it's got 1, 2, 3, 4, 5, 6 electrons. And we're going to take this one, and it's going to go there. Okay, so now this is gone, this is gone, this is gone. Now we have our +3 aluminum ion. But there's a problem here. Sulfur does not have an electron here. So what are we going to do? All right, we're going to get another aluminum. So we get another aluminum, and it's going to have 3 valence electrons. And we're going to color code them so you see them. And so we're going to take this electron here, and we're going to give it to sulfur. Now that sulfur is complete, we can put brackets on it. Oops, negative, sorry. And now that's complete. But wait, this aluminum still has 2 more electrons. Whatever are we going to do? How about we get another sulfur? It's always the answer, right? Now, this one's going to go here, and this one's going to go here. That's going to complete this sulfide, and it's going to be 2-, and that's gone, and that's gone, and that's gone. So now this is a +3. So let's look at our math here. What's 3 + 3? You might have to use 2 hands here. That's +6, right? What is -2, -2, -2? That's right, that's -6. And +6 -6, why, that equals 0. Now remember, our ionic compounds, we want them to equal 0. So as we can see, we're going to need 2 aluminums and 3 sulfurs. 2 + 3s, 3 - 2s to equal 0. So this is going to combine in a 2-to-3 ratio. 2 aluminums to 3 sulfurs. Write small. It's going to take a lot of space here. So our formula is going to be Al2S3. Okay. Rubidium and selenium. Rubidium is our metal, and selenium is our nonmetal here. So rubidium, it is in group 1. It gets 1 valence electron. And selenium is in group 16 or 6A, so it gets 6. Oh, rubidium, it's right there below potassium. So rubidium's even more reactive than potassium. All right, so here's our selenium. Color code. And we can see here that this electron here is going to go there, but we're going to need another one from down there. So we're going to need 2 rubidiums. there's our selenium. And you got that one from a rubidium, and I got that one. So it gained 2 electrons, and it's a -2. +1 + 1 -2 equals 0. So our formula is going to be Rb2Se. All right, strontium and nitrogen. Strontium is a metal. Nitrogen is a nonmetal. Let's find strontium. Oh, there it is right there. Strontium. That's an alkali earth metal. It's in group 2 and has 2 valence electrons. And we'll color code this. All right, and nitrogen. Nitrogen is right here, and it's in group 15 or 5A. It's going to have 5 valence electrons. Now we're going to kind of have the same story here as the aluminum and the sulfur. So I'm going to draw this one out for you. So here's our strontium with its 2 electrons, and here's our nitrogen, and it's going to need 3 electrons. And so we see that these 2 electrons, they're going to go there and there. So these are gone. This is now a strontium ion. It has a +2 charge. But nitrogen needs another electron. So let's get another strontium out there. So here's another strontium with its 2 valence electrons. Okay. And so this one's going to go there. Now our nitrogen is all filled up, and it has a -3 charge. But wait, we still have this 1 electron here for strontium. So what are we going to do here? Well, we're going to get another nitrogen out. Okay, and so this little guy here, he's going to come down here, and there we go. So now this strontium has lost its electrons, and it's now a +2. But wait, we still need 2 more electrons there. What are we going to do? That's right, we're going to get another strontium, and it's going to bring its 2 valence electrons there. And that one goes there, and that one goes there. Now, gone, gone. Nitrogen is full, and it has a -3 charge. And this strontium has lost both its, so it is a +2. Let's look at our math here. +2, +2, +2, that's +6. And then -3, -3, that is -6, and that equals 0, and that is our compound there. It takes 3 strontium ions to counteract 2 nitrogen ions. 3 + 2s, 2 + 3s. That's how that works. Oops, didn't leave room for my electrons there. So our chemical formula is going to be Sr3N2 for strontium nitride. All right, we're almost done here. 2 more to go. All right. Calcium is your metal. Iodine is your nonmetal. And there's calcium goes here. And calcium, do y'all remember calcium? Where it is on the periodic table? Why, it's right there above strontium, right there. And it is in group 2, or 2A. So it's going to get 2 valence electrons. And there they are. Iodine. You know what iodine is, right? What you say when you're dying. Just kidding. All right. Iodine is, why, iodine is a halogen. It is in group 17 or 7A. So it's going to have 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Why, it just needs one more electron to fill its outer shell. So like this one right here could just go right there. Boom, done, right? Well, what about that electron? That's where we're going to need a second iodine. And our formula is going to be CaI2. We need 2 negative 1s to counteract the 1 plus 2. All right, on this last one here, I'm going to show y'all a little secret right here. This is something we're going to do. Now, if we know the charges for these ions, for aluminum, which is the metal, and oxygen, which is the non-metal, okay, so we'll write down here. Now, aluminum, we look at it on the periodic table. There's aluminum. Aluminum's in group 13 or 3A. It has 3 valence electrons. It will lose them and form a +3 ion. So here's what we're going to do. Is we're going to put a +3 right there. Okay. Now, oxygen. Here is oxygen. It is in group 16 or 6A. Has 6 valence electrons, so it's going to gain 2 and form a -2 ion. So we put the O, -2. Here's where the magic happens. I'm going to take this 2, and I'm going to put it down here. And I'm going to lose the negative sign, and I'm going to take this 3, and I'll put it down here. That is the formula for aluminum oxide. In other words, I need 2 plus 3s and 3 minus 2s to equal 0. So now we know that the formula is going to be Al2O3. And so we can kind of reverse engineer this thing and go from the formula to the Lewis dot diagram. And we know we're going to need 2 aluminums. And we're going to need 3 oxygens. +3, +3, -2, -2, -2 equals 0. All right, and now we have finished doing our ionic bonding. Yay! Remember our big ideas here. We want to remember that metals lose electrons to form positive ions. Non-metals gain electrons to form negative ions. And that positive and negative ions attract each other. And that, my friends, is ionic bonding. Yay! And I want to give some special thanks to those who helped me. And that would be Bella.